Hello everyone. So in the last video we have seen RCNN network for object detection. So we have started from RCNN, then fast RCNN, then faster RCNN. But still faster RCNN has a good accuracy, good performance, but they are lacking in terms of speed. So you can say if you want to utilize it for autonomous car, maybe the results are coming very late, while you met with the accident. So then he required a different variety of architecture or different variety of network that is much faster. So there is one network that is known as YOLO. So let's see into the details. So YOLO is one variety of object detection techniques. So YOLO stands for you look on sorry you look only once. So suppose this will be the input image. So then what output YOLO will produce? It will produce something like this. So it will say this is car, this is truck, this is bicycle, this is car, person, and so on. So this is, or you can say traffic light. So this is what YOLO is producing. So now the question is going, what different in the YOLO so that it is faster and it is producing very high quality results as well. So how YOLO works? YOLO first divide the entire image into these boxes, or you can say cell. Now every cell, or you can say one object, is responsibility of the center cell to detect that object. So you can say to detect that person, only this cell is responsible, where we have the center. Maybe some other cells also giving the bounding box is of this person. Then as we discussed, we will utilize the non-max suppression to reduce other bounding boxes. We'll keep only that bounding box which has the maximum probability, or you can say maximum accuracy. So then what exactly it will do? It will take this cell and try to find out this person, right? So suppose you have multiple cells and they are saying this is also person, this is also person, then you will use IOU, intersection or union, and you will use non-max suppression or NMS to figure out which box is more suitable. So we'll say this box is more suitable because both are belong to the same cell. So how this NMS will look like? This NMS will look like, so you have this image, it will feed to the YOLO, and then for each cell, for every cell, it will produce this many objects. So you can say X, Y, W and Z, H value. Then it will give the confidence score of this particular box, right? Then you can say it will produce another one, right? So now if you say it is producing multiple boxes for one cell, then you look for the confidence score which have the highest confidence that will produce by this box, or you can say that box will be selected, right? So this is done through all the cells. So suppose you have, so you can say 1 cross 1 cell here and S cross S cell here. For individual cell it will produce this output here. Now the cell which contain, or which is in the center of that object, that is the responsible for producing the correct bounding box. If other cells are also producing, we'll utilize the NMS to suppress those bounding boxes. So how overall your model will be look like? Suppose you have an input of 448 cross 448, then it will pass through the convolution layer, another convolution layer, and so on, and finally it will produce 7 cross 7 cross 30 output. 7 cross 7 cross 30 means it is ready to produce 30 bounding boxes in one go. That is the way how you decided. Means I want to detect 30 boxes in one go. That is the primary, or you can say very basic YOLO module. Then there is another evolution come, how to find out these boxes. So then a research happened that if you have different variety of boxes, then you have more accuracy, but there is one threshold. So they are saying after getting the bounding box different size, like more than 5, then you will not get very high accuracy. Means if you select 5 different variety of box to detect all the object in an image, that is good enough. Or you can say 5 different boxes are good enough to cover wide variety of objects, right? So you can say for person you will require vertical, but for the car you will require like this, or maybe for the dog you will require like this. So means 5 different variety of boxes is good enough, or you can say 5 variety of boxes will give you enough accuracy, right? Then another change, that YOLO is trained in 2 phases. One in 2 to 4 cross 2 to 4 pictures, and then it will train on 448 cross 448 pictures for the fewer epochs, so that we'll have much better accuracy. Then they saw like it happens in the ImageNet challenge. These are the classifications labels. But if you look into, they form the word tree. Why word tree is important? Suppose I am saying there is a dog, so that is also correct. But I am saying it's a bulldog or Doberman or any other dog, that is also correct. So it happens many classifications are in that way, so that you are saying this is dog also, that is also correct, but you are saying this is a different breed of dog, that which is also correct. So you can say if they are saying labeled as biplane, so it also considered as a airplane or air or other vehicle, because that is also vehicle. So once you say vehicle in the top in the tree, so you are saying vehicle, so then car is also vehicle, you can say motorcycle is also vehicle, plane is also vehicle, ship is also vehicle. So in that way, if it is classified as vehicle, that is also true. But if it is classified as a car, which is for the car, then that is also true. So to make this better detection, we are making a word tree. Now then comes another variant of YOLO, that is the YOLO version 3. So what they are doing, they are better, maybe not faster as you they are close to this, you can say not very fast, but they are very strong. They work on the classification side. So previous version have 45 fps, but this version has 30 fps. But if you look into the real time scenario, 30 fps means 30 frames per second. That is good enough to detect any variety of the object. You do not require very high FPS most of the cases. So what they have done, they have taken very high depth neural convolution neural network for detecting more features. So you can say they are detecting in 3 scales. First in the bigger scale, then second smaller, then third more smaller. So even if you have very tiny object, then also you are able to detect. Maybe you can say you are trying to find out the faces in a classroom, which is very small. So maybe your object, or you can say multiple faces are coming in one cell. You can say one face is here, one face is here, one face is here in this case. But if you look into here, you will have only one face in one cell. So that will help us to detect small size of object as well. So that will improve your accuracy. Now what different here, we are taking the, you can say feedback, or you can say you are taking these features and putting here, so that while you are doing the convolution, we are not dropping very basic elementary features as well, right? That is known as the ResNet, or you can say residual network, right? Now what this residual neural network is doing, while we are dealing with the different variety of network, so we'll see as you are moving forward here, then it happens while you are going looking forward, then your network features are reducing down, their quality is reducing down. But with the help of residual network, you are adding more elementary features here into the next layer. Sorry. Now this will help us in many other ways as well. It will solve the vanishing gradient problem as well. Because once you go back propagate, then as you are connected with the basic features here, then this gradient, whatever is here, that will also connect here, or it will pass here as well while you are doing the back propagation. So this will help us to solve many problems, or you can say help us to solve the vanishing gradient problem as well, right? Now you have some constraint as well. If you are dealing with the dense layer, then output here and output here should have the same nodes or same number of nodes. But if you are using the convolution neural network, then while you will do this, you may be required the padding or pooling. So if you are going from higher dimension to lower dimension, then you will require pooling. But if you are going lower to higher dimension, then you require the padding. So in that way you can apply the residual neural network, right? So now what different scales means, if you have 13 cross 13, then this cell is responsible for that. If you have more, then multiple cells are covered here. Means if you have tiny object, that will also take care by the higher scales, right? Again, if multiple grids are selecting the same objects, then you will use the non-max operation as we discussed to solve this challenge. So whatever have the maximum threshold, or you can say maximum confidence, that will be selected, rest all will be rejected. So with that you will able to solve multi-bounding box problem as well. So what different in YOLO version 5? First, they are using logistic regression, right, to correct, to find out the confidence score. Then they are not using softmax. Why? If you use softmax, then they are not able to implement the word tree as we discussed. So if it is person, then you require many other. So suppose this is a vehicle, then you can say car as well, you can say uh, bus as well, you can say plane as well, you can say ship as well. This is not possible in the softmax, so they are using the logistic classifier to solve this problem. Then as a feature extractor, they are using darknet plus resnet, both models as a feature extractor. So they introduced new darknet 53, which is really very powerful architecture for extracting the features. And as we discussed, they have multi-scale predictions as well, so that you can identify the objects in various dimensions, or we can say various scales. So that is the beauty behind the YOLO version 3. So now YOLO version 4 and 5 is also came into the picture. They are really different in many aspects, so that you can discuss, that you can see details in various platforms where, so you will find version 4 and 5 are closely related to each other, or you can say they are very similar. Version 4 is on the darknet and version 5 on the PyTorch. So they have introduced different variety of training methods in version 4 and 5. So that will help to find out the best output in the in object detection problem, and that is the latest model YOLO version 5. So this is all about the object detection. So we'll catch you in the next video. Thank you.